times as we go on. We will now summarize some of the derivatives that we have already discussed and add to that list some standard derivatives, and that will be the list that you need to really remember. Alright, let's start with this. D by dx of a over x is negative a over x squared. D by dx of square root of x, the derivative of square root of x with respect to x is 1 over 2 square root of x. The derivative of a constant with respect to any variable is 0. The derivative of ax, d by dx of ax equal to a. Derivative of 2x equal to 2. Derivative of 5x with respect to x is 5, and so on. Now, these are the 4 results we have seen so far. And also I want you to learn some of the derivatives of trigonometric functions. I'm not going to prove them to you, but I'm going to give you the results. And these results are going to be used right through the course. So please learn them. Derivative of sine x with respect to x is cos x. The derivative of cos x with respect to x is negative sine x. The derivative of tan x with respect to x is secant squared x. The derivative of cotangent x with respect to x is negative cosecant squared x. The derivative of secant x with respect to x is secant x tan x. And finally, the derivative of cosecant x is negative cot x cosecant x. Now, these 10 standard integrals, you must remember, there's no other way. So write them down several times. The way to learn calculus is actually to write them down, not to read or listen to. You need to write down and learn. Alright, what we're going to do now is to apply some of these concepts in solving problems in our everyday life. Now, the most important area where derivatives are used in solving problems is the problems involving position, velocity, acceleration, and so on. Well, if you have the position of an object described by a function, and if you find the derivative, the rate of change of position is what we call velocity. Similarly, the rate of change of velocity is the acceleration. So if I give you the position function, you can find the velocity function by taking its derivative. If I give you the velocity function, you can find the acceleration function by finding the derivative of the velocity function. But let me illustrate that with a couple of examples. Alright, let's say x of t equal to 2t squared minus 5t plus 3 is the position function. This function describes where the object is at a given time. For example, if I want to find the position at time t equal 1, I just put t equal 1 in the function. So this is your position function. And if I now find the derivative of this, if I say x prime of t, you understand what that means. X prime is the derivative of the x function, and that will be your velocity function. Now, that will be, what is the derivative of 2t squared? That will be 4t. And what is the derivative of minus 5t? It's minus 5. So this is the velocity function. And the acceleration function is obtained by taking the derivative of the velocity function. And that will be equal to 4. Now, this can also be written as, look at this, a of t is also written as the second derivative of the position function. What is the meaning of the second derivative? Now, this is the position function, 2t squared minus 5t plus 3. You find the derivative of that, you find the first derivative, and that is 4t minus 5. If you find the derivative of that again, it is called the second derivative of x. And the second derivative of x is 4. So, velocity is the first derivative of the position function. Velocity is the rate of change of position. Acceleration is the first derivative of the velocity function. Also the same as the second derivative of the position function. Alright, we will develop these ideas again as we move on. So, velocity of a moving object is the rate of change of its position. If v of t is the velocity and x of t is the position function, then we say v of t equal to dx over dt, or x prime of t. That's right. Velocity is the derivative of the position function. Acceleration is the rate of change of velocity, which means acceleration is the derivative of the velocity function. If a of t is the acceleration function and v of t is the velocity function, then we say a of t equal to dv by dt, which is v prime. But v prime is the first derivative of the position function. Therefore, a will be the second derivative of the position function. The derivative of dx by dt is called if you have the first derivative dx by dt, and you then take the derivative of that again, it is called the second derivative of x. So dx by dt is the first derivative of x. If you find the derivative of that again, you get the second derivative. Again, the first derivative of x is the velocity, dx by dt. And if you take the derivative of that again, you get the acceleration. And look at the way we write the second derivative. This is one of the notations. D squared x over dt squared. Or also, we write it as x double prime. Alright? Now, acceleration is the second derivative of the position function. That is, a of t is d squared x over dt squared, or a of t is the same as x double prime. V of t is the first derivative of the position function. A of t is the second derivative of the position function. I want you to know these concepts, have some understanding of these concepts. All right? Okay. Let's do a problem using that. The position in meters of an object is given by x of t equal to t squared minus 3 over t, where t is measured in seconds. Find its position at t equal to 1. If this is the position function, how do you find the position at t equal to 1? Simply replace t by 1. 2. Find its velocity at t equal to 1. Well, we will do that as we go on. In number 1, we need to find the position at t equal to 1. X of 1 is obtained by replacing t in this equation by 1. That would be 1 squared minus 3 over 1. That is negative 2 meters. Is that right? 1 minus 3 is negative 2 meters. It tells you that at t equal to 1 second, the object is 2 meters to the left of the origin. That's what it means, negative 2 meters. 2 meters to the left of the origin. And at that time, what is its velocity? That is our second position. And you know that velocity is the derivative of the position function. And the position function is this. X of t is t squared minus 3 over t. So to find the velocity, we find the derivative of that position function. What is the derivative of t squared minus 3 over t with respect to t? We take the derivative of each term. Use the power rule. Alright, now tell me. Leave the first term. I want you to ask this. What is the derivative of 3 over t with respect to t? We just did that. The derivative of a over t with respect to t is negative a over t squared. The derivative of 3 over t is negative 3 over t squared. So this is the derivative of t squared minus the derivative of 3 over t. And what is the derivative of t squared? The derivative of t squared is 2t to the power of 1, which is 2t, and minus, now watch those signs there, minus the derivative of 3 over t is negative 3 over t squared. And now combine the two negative signs, you get the derivative, the velocity function is 2t plus 3 over t squared. And we want to find the velocity at t equal to 1. In other words, we want to find the rate of change of the position function at the instant when t equal to 1. In other words, we need to find v of 1. v of 1 is, replace your t by 1 there. 2 times 1 plus 3 over 1, which is 5 meters per second. What it tells you is that at t equal to 1 second, that object is 2 meters to the left of the origin, and at that instant, its velocity is 5 meters per second. And as time changes, these things will change. The position will change, the velocity will change. Alright, how about the acceleration? Find the acceleration of this. Well, acceleration is the rate of change of velocity. Now the velocity function we obtained is this. v of t is 2t plus 3 over t squared. And to find the acceleration, we find the derivative of this. a of t is dv by dt, derivative of velocity with respect to time. That will be d by dt of 2t plus 3 over t squared, which is derivative of 2t plus the derivative of 3 over t squared. Well, it's easy to find the derivative of 2t, but to find the derivative of 3 over t squared, you need to write it in a form where we can use the power rule. That means the t squared from the denominator, we should take it up to the numerator. What will that become? T squared moved from the denominator will become t to the power of negative 2 on the numerator. So that will be derivative of 2t plus derivative of 3 over t squared is 3 times t to the power of negative 2. We are now in a position to use our power rule. What is the derivative of 2t with respect to t? That is 2. What is the derivative of 3t to the negative 2 with respect to t? Use the power rule in your mind. It will be a times n, 3 times negative 2, times t to the power of n minus 1, negative 2 minus 1. Let's write that down. Derivative of 2t with respect to 2 is 2, plus the derivative of 3t to the negative 2 is 3 times negative 2, 3 times negative 2, times t to the power of n minus 1, negative 2 minus 1. And that is, this will make it negative, 2 minus 3 times 2 is 6, t to the power of t to the power of negative 3. And now in the result, we cannot leave it with a negative power. We must take it to the denominator and give it a positive power. So this will be 2 minus 6 over t to the power of 3. and that is the derivative of the velocity function. So this is the acceleration function, and we need to find the acceleration